welcome to this channel. Checking calculus 1 typical past exam questions, and those past questions involve differentiation, integration, limits, and lots more. Without further ado, let's go to question 1. The question 1, we have use logarithmic differentiation to find the y dx if y is equal to this function. The first step to do, or the first step to take when you're using logarithmic differentiation, is to take the ln, the natural logarithm of both sides. And that will give us ln of y equal to ln of that function. That function is this. We're going to apply the logarithm rules. At the numerator, we have a product of two items, this one and this one. So this is going to give us ln y. Ln of products will give you ln of this function, and then plus ln of the second function. And then for the division, it's going to be what? Minus the function you have there. That's what? Ln of that function. Let me recap that again. When you take a ln of a product, it's going to be what? It's going to turn to addition of each of those products. And then for division, it's going to be what? Minus. This will give us ln y equal to this power here will come to the front. And so we have that. Then plus this one, ln of e to power x is going to give you x, because ln is a logarithm to base e. Okay, and the function here is what? Is e. So log of e to base e is what? Is 1. In a nutshell, ln of e is what? Is 1. And don't forget that this power will come to the front. This will be x ln of e functions. Why this one is what? Is 1. And then we have what? Minus ln of this. Then the next thing to do now is to differentiate implicitly respect to x. But don't forget, y here is this one. If you differentiate this one, it's going to give you 1 over y dy dx. I'm going to explain that shortly. And here is a product rule. You have two functions there. This one, sine x, and this one. So we're going to apply product rule. So differentiate the sine x, and that will give us cos x. Keep this one constant. Then plus. You now differentiate this one now, and keep this one constant. Keep your sine x constant, and differentiate ln of this function. Differentiate this. I'm going to put prime on it. That's a ddx of this function. Okay, and then plus what? The derivative of this one is what? Is 1, and then minus. This one will give us what? When you are differentiating ln of a function, it's going to be 1 over x cubed plus 1, and then times the derivative of that function, and that's 3x cubed. Let's quickly differentiate this ln of this function. We're going to apply chain rule for this one. It's going to be ln. I'm making this one ln x as what? As v, where my v is what? Ln x. So you're going to differentiate this one with respect to v, and that's 1 over v. This one with respect to x, that's what? 1 over x. So then multiply the two together, and that will give you what? 1 over x. Your v is what? Your v is ln x. So that's the derivative of this function. You can remove this 1 over y, this y, you can remove it from here. So multiply through by y. So we have dy dx equal to what? Equal to y times. So that's what we have now. The next thing to do now is to just plug back your function y, which we have, which is this. Plug it back to this place, and that's finished that solution. We have the 1b of the question. Evaluate limits as x tends to infinity. What we're going to do is to do direct substitution. And if you do that, you're going to have, whenever you see this function x, put your infinity there. This will be equal to e to power infinity plus 1 over e to power infinity. This will give you, by the time you substitute, it's going to give you infinity. Okay, this one will give you 0. So this will give you what? Infinity over infinity. Okay, and when you have infinity over infinity, we call it indeterminate. Then the next thing to do when you have this format, infinity, either infinity over infinity or 0 over 0, then in that case now, we use a L'Hopital rule when you have the case of indeterminate function. So what is the meaning of L'Hopital rule? What you're going to do is just to differentiate your function. You differentiate your function. Differentiate this function. This will be what? Minus what? Minus this all over. Derivative of x is 1. And this one is what? Plus 1 over what? 1 over x. Then after that, do your direct substitution. And that will give you what? E to power infinity. That's infinity. Plus. This one will give you 0. I've done that here. All over 1 plus 1 over infinity, that's 0. Okay.